Hello everyone and welcome to another video. In this video, we're going to learn two algorithms, bubble sort and insertion sort. Alright, so here we go. Sorting is a way to put the items in a collection from least to greatest or vice versa. And like I said, the two sorting algorithms that we're going to learn today are called bubble and insertion sort. Both are sorting algorithms and they have the exact same worst case performances. They're of big O notation. They have big O notation of n squared for both comparisons and swaps they must do. So overall, in summary, bubble sort is a type of a sorting algorithm where it compares a pair of values and swap their location if they're not sorted. So let's say we had a list of animal names and we are sorting them alphabetically. And in this scenario here, I have cat and bear. Well, that is not sorted. So we're just going to swap those two and say that, well, if we swap those two, when we just consider them as pairs of values, we can consider them as sorted. Whereas insertion sort is throughout the array that we look at, we grab a value and we just put it in the right location into the sorted list portion, basically, because it's going to assume that, well, the very first item has no comparison, so it is sorted. And then when it sees the next one, it either puts it in the proper place or leave it alone. So in this case, if we had our sorted list, insertion sorted list is as bear, cat, duck, fox, that is sorted, but we ran into this element called dog. And what it's going to do is we'll compare dog to fox, well, dog is less than fox. And then it will compare dog to duck, it is less than duck. And it will compare dog and cat, it's going to know that it's greater than cat. So it's going to place it at that location because we found a proper place for that value. So bubble sort is a sorting algorithm that is based upon comparing values, pairs of values, and swapping their place if necessary. So overall idea is that L at I and L at I minus 1, we look at those two locations, and if they're not sorted, we swap location and repeat as you increase I and until no swap occurs. So we will be looking at a little animation. Unfortunately, the animation continued. I was hoping that it would stop and whatnot. All right, so right now we are looking at pairs 1, 3, that is sorted. 3, 5 is sorted. However, if we look at the pairs of 5 and 2, that is not sorted. So we're going to swap those two locations in place and we get 2 and 5. And if we continue to do this over and over and over again until no swaps occur, we are guaranteed that this list will be sorted. All right, so that's the bubble sort algorithm. We're not going to worry about it too much because we're going to be coding on VS Code. So let's move on to insertion sort. Insertion sort is a sorting algorithm that iterates and sorts from the bottom one element at a time. Overall idea, since a single item in a list is considered to be sorted, we move on to the next value in that list, and we'll consider that the very starting value as a sorted list. And then as we continue to look at the next values in our list, if when we compare it to our previous values, if it's less than those values, we're going to put it in the proper place and so on. So in this situation here, 6 is considered to be sorted. 5 is going to move because it's not in its sorted place. So we're going to swap it with 5 and 6 right there. And then we have 3. 3 is less than 6, but it's also less than 5. So we're going to put it in its proper location. And now we have a sorted list of 3, 5, 6. And we have the unsorted list at the right side of 1, 8, 7, 2, 4. And what we get to do is continue to move those values. And eventually this will get sorted. And this is our insertion sort algorithm. So with all those algorithms introduced, let's get programming. What you see here is now my Visual Studio Code. What we're going to do is have create two functions, and we're going to create each function. So I have wrote the pseudocode for bubble sort, and underneath I've wrote the pseudocode for insertion sort. So what we're going to do is code our bubble sort first. Okay. It says let a be a list, n be a length of a. Here, what we're going to do is that both functions are going to be mutating functions, and it's going to sort any inputs that we provide to these functions as a comparable values within a list, and it's going to sort them from least to greatest. And it says here, well, repeat until swapped is false. So it means that we have a variable called swaps, and as we're going to set it to true. And we're going to say while the swap variable is true, we're going to do some sort of Python code. But right now I have these two values. Okay. And then it says for I from 1 to n minus 1 inclusively. So that one, we're going to set swap equals to false here because that's our very first step. We're always going to assume that the swap has occurred. And as soon as we get into this while loop, we're going to say that, hey, we're going to turn it to false. And once we do a swap operation, we're going to turn it to true. It says for I and 1 to n minus 1 inclusively. So that is for I in range, starting from 1 up to the length of our A list. And we're going to go up to that value. Okay. And then we're going to say the following. We're going to write this if statement here. If the left value of or if the value at I minus 1 is greater than a at I, which means that the left value is greater than the right value. Okay, so we can say that if our A list at I minus 1 is greater than a list at I, we need to swap those values. And then we set swap to true. So a swap must occur within this if statement, and we continue to do this forever and forever and forever until swapped doesn't remains false, as in we never did a swap in this situation. Here we go. How to do a swap. How to do a mutable swap in Python. It's very simple. We want to have this value as an A list at I minus 1 to have the value at a underscore list at I. We just will write that A underscore I minus 1. Okay. Comma A list at I is going to be equal to what we wrote opposite here. This is the most Pythonic way for us to swap two values in a list, since lists are mutable, and we get to reassign those values at these indexes. We're saying that in this code here, A underscore list at I minus 1 is now going to have the value at A underscore list at I, whereas the A underscore list at I is going to have the value at A minus 1. A list underscore I minus 1. So this is the Pythonic way, the most Python way to do this. But if you didn't know how to do this, a secondary way, swap values, is using a temporary variable. We can say the temp variable is equal to A list at I, and then we're going to update A list at I to be equal to whatever I minus 1. A minus 1 is going to have the value from A list. A list at I is going to have the value at A list at I minus 1, and then A list at I minus 1 is going to have the value at temporary. So this would have been our secondary way to convert two values in its place by using a variable called temporary. You could have called it anything, or just a placeholder, so I called it temp, and this is how you can swap values like so if you were swapping two values, but I'm going to turn that off. Okay. And now what we can do is we can test our function. We can test our bubble sort function by running this function to a unsorted list. Okay, so at this moment, I have created a variable called fruits. It holds random names of fruits, and what we're going to do is sort them in alphabetical order from the A to Z in this scenario. So what we're going to do now is we have this unsorted list of fruit names. We're going to ask, well, we're going to run bubble sort, which was called bubble, and we're going to run it on fruits. Right. And then we can have a print statement, f string. Well, it should be after the fruits variable. We can say fruits, the fruit list before sorting looks like fruits, and we'll see what happens if we were to do after sorting, because we don't need to reassign the value of fruits here because we're mutating our list. And let's see our code get executed here. And if we sort it, all right, before sorting it, it will do apple, honeydew, cherry, banana, elderberry, date, fig, grape. Whereas after sorting, it will give us apple, banana, cherry, date, elderberry, fig, grape, and honeydew. So it will sort our names of fruits in order from A to Z in alphabetical order. And this allows us to swap neighbors consistently until this doesn't turn true again, because we turn that value to true anytime we do any swap. And if this is never true after we've done many series of swaps, it will remain false, and we will be able to exit our while loop and allow our function to finish, and that's how you can do a bubble sort. It says let A be a list, I and J are both indices. So what we're going to do is, well, I don't want to call the variable A, so I have a list being given to this insertion sort. And then we're going to say that, well, in this case here, I is set to 1, just like what our pseudocode says. And we're going to say, well, I is less than the length of our A list. We're copying it over, and we're going to say that J is going to be updated to I. And I. Then it's going to say that, well, y, j is greater than 0, and a list at j minus 1 is greater than a list at j. As in any time we are looking at a certain value, so example, banana, right? Right now, if j was targeting banana and j is greater than 0, so I made this side of the while loop true, and it's going to say that a underscore list j minus 1 is greater than a minus j, as in, well, cherry is greater than banana, the one left to it. So we're going to do some swap. It says swap aj, all that. So this is how we can do a swap like so. We're going to copy that over, and we learned that this is a Pythonic way to do a swap, and we're going to swap using the j index, because in this while loop we're referencing the j index counter variable. So we have those swapped, and then in this loop we're going to ask j to decrease by 1 by saying j minus 1 until we get to 0. Okay, and while this inner for loop is done, inner while loop is done, after that we're going to make sure that I is going to be increasing by 1 at every step. So we can actually simplify that by writing I minus equal 1. And we're going to be making sure that we're increasing by 1. We're increasing I by 1 at every loop so that we can terminate this loop. And let's see what the result with this one would be. So let's say print. We can say print. We're going to do insertion sort on fruits. And then we're going to get the same sorted list of fruits because we have apple, banana, cherry, date, elderberry, fig, grape, and honeydew. So they're all matching from our previously unsorted list of fruit names. And one thing really cool about all these sorting algorithms is that, well, they exist already. So if you just understand how the pseudocode works, you should be able to easily translate them into Python code and use them. But in a future video, probably we'll do a deeper dive in terms of how we know that these are, they have the complexity of big O of n squared. Anyways, as always, thank you for watching and stay classy.